So let's take a look at number 1. At least the first part of it shouldn't be that bad. A little distributive property. Just crank out a little multiplication here. Alright, so I'm going to have a 2x squared minus 10x plus 6.
Oh yeah, wouldn't it be 2x to the 4th?
Because we're multiplying only coefficients.
Oh.
If there was a power involved, if that whole thing was to the second power, then you would have an x to the 4th. All right. So then the next part, you have this little understood 1 in front of the binomial. That creates a -1 multiplier, which we could then multiply. All right, distributive property again. So -1 times 3x squared would become -3x squared. -1 times 7 would become -7. All right. The alternative to that would be to just say, okay, well, I'm subtracting something in parentheses, so I just reverse all the signs within the parentheses. I personally like reasoning it out this way better because it shows an actual operation that's consistent with everything else that we've been learning in this course. It's not some magical rule that you have to just know. It's grounded in a property that we've been working with all along. All right, so same ideas here, where we're multiplying by 2, except we're multiplying by a -1. All right. Then all we have to do is combine our like terms. So 2x squared and -3x squared are like each other. -x squared. There's nothing like the -10x, so we'll leave that as is. And then we have 6, which is like the -7, -1. Boom. And so that would be our simplified form. All right. So, number 2 is a little crazier. Well, crazy in a different way. This time we're raising to different powers. So we're going to take each part and raise it to the 3rd power for the first set of parentheses. So that's going to give me a -4 to the 3rd, x cubed to the 3rd, y to the 4th to the 3rd. Then for the second one, we're raising each part to the 4th, so that'd be a -2 to the 4th, an x to the 4th. I'm going to write that as x to the 1st to the 4th, x to the 5th to the 4th. All right. So we have to address the numerical parts. Whether you do it in your head or on the calculator is up to you. All right, but this is going to be -64, x to the 9th, y to the 12th, -16. I like drawing these little arrows. X to the 4th, y to the 20th. All right, so we have all those ingredients mixed together. So that's fun. So I have to multiply 64 by 16. So you just take, 16 is 2 to the 4th power, so you're just doubling 64 4 times. So 128, 236, is that 1024? Well, I'm going to write 1024 down, and you'll tell me if I'm right or wrong. Yeah, I'm right? Okay, cool. All right, for the x terms, I'm going to keep the base and add the exponents. So the 9 plus the 4 is going to give me a 13. I'll do the same thing for the y's. Keep the base and add the exponents. So y to the 32nd. All right, so you're multiplying exponents if it's a power to a power. You're adding exponents if you're multiplying the monomials. All right, so it's something to get used to, but it's very doable. Doable. There was only 2 problems, right? Okay, good. All right, so multiplying polynomials. Take a bunch of different forms. It could be a monomial multiplied by a polynomial, or it could be, we've already done monomial by a monomial, so that's this case here. But it could also be polynomial by a polynomial. All right, so we'll get to that in a little bit. So I'll do a couple of examples where it's just monomial by a polynomial, and then we'll kind of hop ahead and I'll give you some time to practice. All right, so good news is when you're multiplying a monomial, so that single-termed algebraic expression, by a polynomial, so an expression with more than one term, you're still following the distributive property. All right, so we're still going to distribute. The only thing is we're not just distributing a number, so we have to account for exponents now. All right, so I'm taking 3n, I'm multiplying it by n squared, and then I'm taking the 3n and multiplying it by 2n. If it helps, it's not always necessary for some folks. I mean, if you see it and you got it, that's fine. But if you need to, put little exponents in here. If it's just an n all by itself, it's n to the first. Just to kind of remind yourself what it is that you're adding. All right, so I have an n to the first and an n to the second. So that's a highlighter still. 3n to what power? Third. All right, for the other piece, I'm looking at an n to the first and an n to the first again. So 6, because 3 times 2 is 6, n to the second. All right, so we're multiplying each part by whatever is on the outside. And then simplifying. The key is simplifying. Do you have to show this, all this work that I did here in purple? No. If you can get to the black without showing the purple, that's great. Eventually, you're all going to be able to do that. Or, unfortunately, even if you're not able to do it, you'll be expected to do it because it'll be just like the small step within a larger problem. So just moving forward into Algebra 2 and pre-calculus and so on. These are minor details. They're a big deal now, but they'll become minor details later on. So you want it to become fluent, all right? So number 2 is along the same lines. Actually, 2, 3, 4, 5, they're all kind of the same deal, but let's hop over to number 6 because that's the only one that looks kind of juicy. Again, I'm distributing the negative 2/3 x to the second to each part within the trinomial here. So I'm going to show the steps, but again, if you can do it in your head, then great. So that negative 2/3 x to the second is getting multiplied by each part. All right, so each part getting multiplied by the 2x to the 2/3 x to the second, negative. So just kind of looking across the board, it looks like the first pair that are going to be multiplied, they're in the right form, so I don't have to worry about that. If I want to, I want to, but maybe you don't want to. I'm going to put a little power of 1 there, just to remind myself that I'm adding those exponents. All right, the 6 over here doesn't have an x. You could write an x to the 0 next to it if you wanted to, but I don't think that serves really any kind of purpose. All right, so that's what it would be equivalent to. So anyway, I'm going to multiply coefficients and then keep the base and add the exponents. So negative 2/3 times negative 9 is what? 6. So 6x to the 4th. Then negative 2/3 times 3. So negative 2x to the 3rd. And then negative 2/3 times 6. Negative, say it again. Negative 4x to the 3rd power? Second power. Yeah, we got that, but we don't have anything to add with it. All right, so a little fractional stuff going on here, but not too bad. And again, do it on your calculator if it's not something you want to do in your head. All right. But do it. That's the important thing, because if you're waiting for me to do all the mental math for you, or another student, the only thing I can promise you that will happen when you allow that to occur in class is that me and those other students who actually do it, we're gonna get really good at mental math. All right, so you'll be in the room when other people are getting good at mental math. All right, so I mean, if that makes you feel good, then by all means, go for it. You know, just be a bystander, just be a person who kind of watches it all happen. You'll be in the presence of greatness, and that's probably worth something. You know, to say that you knew a person who is possibly a genius or something along those lines, you know, maybe even before they were great, you know, like they made a name for themselves, you know, and so you can actually just sit there and just be like, oh wow, okay, now I can watch so-and-so do some mental math and share their wisdom with us. I don't know if it's going to help you during a test. You know, I don't know if it's going to help you down the line at any point, but you know that they can feel good about themselves knowing that they're the star of the show. All right. All of that is to say that please try some of these, like when we're doing it together. Actually, you know, if you're not doing it in your head, I should at least hear some of the. I don't have a calculator on me, but you know the distinct sound of fingers tapping keys on a calculator?
Yeah.
Yeah, those sounds. Yeah, that's what I like to hear. You know, so when I say something like negative 2/3 times negative 9, you're either doing something like that, or faking it, just to make me feel better, or you're actually trying to do it in your head. That would be even better. You know, so it's a muscle. It needs to be exercised like any other. You know, so we'll see how it goes. It's somewhere between mild and medium. It's not even, like, I wouldn't even categorize it as medium. Right? So it's got a little tanginess to it. It's got some good flavor, some savory. It's got some body to it, but and a nice aftertaste. Nothing that will make you feel uncomfortable later on. All right. So that's really all we're talking about here. What does double distribute mean? It means distribute twice. Yeah. So, oh, mind blown, right? So let's do that. And now the only question that might be going through your mind is, if you haven't seen this before, is all right, I'm going to double distribute, meaning I'm going to distribute twice. What am I going to distribute twice? Well, we have a two-termed expression that's acting like the coefficient of another expression. So what I'm going to do is I am going to take the first term of that expression and distribute it. So I'm going to get x multiplied by x. And then x multiplied by 5. All right, so I'm showing probably way too much detail here in terms of, you know, the operation, but you'll see it's for the best, and then later on we'll streamline it a little bit. All right, so I've distributed successfully. This is basically pretending that the 4 is not there. If x were the only coefficient, what would the expression become when simplified? We'd multiply the x by the x and the x by the 5. All right, so let's do the same thing. But now we'll do it with the 4. So, plus
Oh, wow.
4x, 4 times x, plus 4 times 5.
Simple.
All right, x times x is what?
2x.
X squared.
Might be
All right, because we're adding exponents. All right, x times 5 is just 5x. 4 times x is just 4x. And 4 times 5 is? Oh, for the love of Christmas. 20, thank you. I mean, I knew when you, like, negative 2/3 times 9, you're like, I just don't feel like thinking right now. Okay, I get it. But 4 times 5, come on. Gotta give me that one quick. All right, we got some like terms there. So x squared plus 9x plus 20. All right, and simplify. All right, and that's the process. That's all you have to do, distribute one term at a time. It's just a question of, okay, well, it can't be that simple. How is he going to try to trick us with this? Well, you'll see. Right now, number 14. Because you look at x minus 1 squared, and instinctively you might say, okay, well, I'll just raise each part to the second power. Fun fact, this is not the same as x squared plus 1. You can't just take the x and square it and the negative 1 and square it and just call it a day. All right, so not true. Not true. Completely wrong. Terrible. Disastrous. Universe destroyed if you do stuff that way. All right, so instead, let's write it as x minus 1 times x minus 1, because when you square something, you're multiplying it by itself, yeah? Okay. So,
0.
let's take the x and distribute it through to the other binomial. Because it is a power of 2. All right, so if I take the x and multiply it by the first x, I get, I'll write it as x times x, but it's going to be x squared. All right. I'm going to take the x and multiply it by the negative 1, so plus x times negative 1, or minus x, minus 1 times x, however you want to write it. Then I'm going to distribute the negative 1, so negative 1 times x, and then negative 1 times negative 1. All right, you want to keep the sign associations. All right, so if it was positive in the original binomial, it's going to be a positive multiplier. So it's a positive x multiplied by a positive x. A positive x multiplied by a negative 1. Negative 1 times an x. A negative 1 times a negative 1. Okay. So x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is what? Positive 1. Two negatives make a positive. All right. We have some like terms here. Nothing is like the x squared. Nothing is like the positive 1. So we're looking at x squared. What are the two inner terms going to become when you combine? Negative 2x, and then we would have the positive 1 at the end. So they all kind of boil down the same way. Just follow the same approach. Take the first term in the binomial on the outside. Take the first term, multiply it by each term. And take the second term, multiply it by each term. Simplify, and you should end up with an expression in this form. All right. What we're looking for is an expression in descending order. That's the preference. I'm not going to write that down, but we want it to be in order of exponent from highest to lowest. All right, so that's what we call descending order. So the highest exponent leaves it off, then the next highest, and the next highest until you're out of exponents. All right, that's in terms of structure what we're looking for. Will I take off credit if you don't have it in the proper order? It all depends on the instructions. All right, so if I just say simplify, you give it to me in whatever order you want. But if I say put it in descending order, if I say put it in order of highest to lowest exponents, if I'm very specific about it, then you would need to have it in the proper format. And obviously, if it's a multiple choice question, you have to choose the one that is correct, and odds are it's going to be in the proper format. All right. So, what do we do?